The next important meter is Synchroscope. So now already we have completed the power factor meter. The next important meter is Synchroscope. So a Synchroscope is a device which shows the correct instant at which the two systems are synchronized. Already in the machine 2, we have studied that synchronization of alternator which is required to operate two alternators in parallel. Do you remember? When we need to require to operate two alternators in parallel, that time these two alternators need to be in synchronized. The term synchronized means the machine of equal frequency and voltage are operating parallel to each other. Okay, so in electrical power system, the Synchroscope is a device which indicates the degree to which two systems are synchronized with each other. So Synchroscope gives the easiest way to check where the alternators or any two systems are synchronized or not. So do you remember the conditions of synchronization? The Synchroscope determines the exact instant where the condition of synchronizing is satisfied. These conditions are, so try to recollect the conditions of the synchronization of alternator. So number one, the alternator should have equal magnitude of voltage. Number two, they should have same frequency. And the number three, they should have same phase sequence. Here, the alternator should have equal magnitude of voltage, same frequency, and the same phase sequence. So those three things you need to measure to operate two systems in synchronization. So the synchronization is checked by your Synchroscope. So this is the operating construction of a Synchroscope. So what is happening? There is a three-limb transformer and a dynamometer type instrument. Here, there is the construction of the Synchroscope given by there are a three-limb transformer and a dynamometer type instrument. What is happening? There are two outer limbs. The first outer limb is connected with the two phases of the bus bar which is previously connected with the alternator, which is previously connected on the system or the previous system. And the another outer is connected with the another two phases which need to synchronize. That is, this was the old alternator and this was the another alternator which need to come in the system. Here, so that is known as, here are two outer limbs. And in the middle outer limb and the middle limb, we are connecting a lamp. Now, there is another dynamometer type instrument which is connected in the system. So try to understand the construction of the Synchroscope. So it consists of a three-limb transformer and an electrodynamic instrument. Here, a three-limb transformer and the electrodynamic instrument. Here it is. The lower instrument is known as electrodynamic instrument. The winding on one outer limb is connected with the bus bars and the winding on the other outer limb is connected with the incoming alternator. Here, one outer winding is connected with the bus bar and the other outer winding is connected with the incoming alternator. The winding on the central limb of the transformer is connected to a lamp. As shown here, the central winding is connected with the lamp. The winding on the outer limbs produce two fluxes, obviously, as we are providing two different phase supply. So this two alternate side will produce two fluxes. Two fluxes flows through the central limb, but the resultant flux is obtained, which is the phasor sum of the two fluxes. Do you remember the operating principle of the transformer? As there are two different fluxes is produced, so the central limb will produce the phasor sum of the two fluxes. This resultant flux induces an EMF in the central limit winding. Okay. The outer winding is so arranged that when the voltage of the bus bar and of the incoming alternator are in limit are added up, and the induced EMF in the central limit is maximum. As a result, the lamp glows with maximum brightness. Clear? The outer winding are arranged when the voltages of the bus bar and the incoming are in limit. Means when the incoming bus bar and the old bus bar are in the same synchronization, then the bulb will glow. The fluxes will be added up. This way the arrangement is being done. That is, this flux and this two outer flux will add up, and the lamp will glow with its maximum brightness. Okay, but when they will be out of that, there will be the synchronoscope will not glow the bulb. So the working, when the two voltages are 180-degree out of phase, if the voltages are not equal, the bulb glow will not be there. And if it is 180-degree out of phase, means the resultant flux is zero and no EMF induced in the central limb winding. Thus, the lamp does not glow. Clear? So, as the two flux winding will produce two separate flux, it will add up. If those are equal in the phase, then the bulb will glow. If the phase sequence is 180-degree apart, the bulb will not glow. Clear? If everything is synchronized, then the bulb will glow. If it is not, the bulb will not glow. Next, if the frequency of the incoming alternator is different from the supply frequency, if the frequency of the incoming alternator is different, the lamp will flicker and the frequency of the flickering is equal to the difference of the two frequencies. Now, first of all, first condition is clear that the alternator should have equal magnitude of voltage. Clear? So it will produce, if it is equal, then the bulb will add up. If it is not, then it will not glow. The second condition is that it have same frequency. So this same frequency is being checked. The same frequency is being checked by the lamp. If the frequency is same, the bulb will continuously glow. But if there is a frequency difference from the bus bar with the incoming alternator, the bulb will not glow continuously. It will flicker, it will on off, on off, on off. Okay. This on off frequency will show you the difference of frequency between the bus bar and the incoming alternator. Here, the lamp will flicker and the flicker frequency will show you the difference of frequency. But there is a problem. This difference of frequency will not show you it is in the incoming side or it is in the bus bar side. Means the incoming alternator have more frequency or the less frequency, it will not show. This difference means the alternator frequency difference can be checked by this dynamometer instrument. Clear? But the flickering of the lamp cannot indicate whether the incoming alternator is fast or slow. For this purpose, an electrodynamic instrument is provided with the arrangement. So, when this alternator having the frequency more than the bus bar, then the pointer will move towards the F direction. If the frequency of the incoming alternator is less than the bus bar frequency, then it will move you to the slow direction. Those things is checked by this moving arrangement here. For the fixed coil, we are taking the supply from the bus bar, but we are taking the incoming alternator for the moving. If there is a frequency difference, and this frequency difference showing by this dynamometer instrument here. So this is the construction and working of your synchronoscope. Okay, okay. The synchronoscope will very much useful, especially for the parallel operation of alternator, which we have studied in the machine 2. Here, just have a small recap. Three winding transformer, and in the mid central limb you are having a lamp. That lamp will show you the synchronization between the bus bar and the incoming alternator, or it will show you the synchronization between the two systems. Here, this is very important, and this synchroscope have a very lot of advantages. It can be used if we don't need to go for any other experiment to check the synchronization. We can easily do the synchronization. We can easily check the synchronization by using this synchroscope. Okay, so, so this is the end of the topic synchroscope.